Understanding how average kinetic energy scales with temperature. Now, this looks like a humdinger of a question to answer, but all it is testing is that you understand the relationship between the energy, the kinetic energy of an ideal gas and its temperature. The only thing that the kinetic energy depends on is its temperature. So it's actually given by the Boltzmann equation, which we won't go into, for an ideal gas, which is 3/2 times K subscript B, which is the Boltzmann constant, times temperature gives you kinetic energy. But we're just going to go with kinetic energy is proportionate to temperature. So I'll draw my little symbol for proportionality. Kinetic energy is proportionate to temperature, because 3/2 times the Boltzmann constant Kb is just some kind of constant of proportionality. That's all you need to worry about. So all we have to work out then is the higher the temperature, the higher the kinetic energy, the lower the temperature, the lower the kinetic energy. And Alex is asking for 1 is the lowest kinetic energy, and obviously out of 5, 5 is going to be the highest kinetic energy. So what we don't care about is how many moles of stuff we have and how much pressure we have. All we care about is the temperature. They're given in Celsius, so you've got to watch out because the Celsius scale goes below 0. Okay, so the highest temperature I can see is 33, so that is going to correspond to the highest kinetic energy, so that'll be 5, which we're defining as the highest. The lowest temperature here is -5, so that'll be 1, that is the lowest, and then everything in between, let's see, 33, then the next highest would be 4, then 3, if I could push the right button, then 2. So going from the highest kinetic energy to the lowest would be 5, 4, 3, 2, 1. So all you have to worry about is temperature. So if I do a quick rinse and repeat, I think you'll see sometimes you get a lot of negative temperatures given to you. Here we go. So just be a little bit cautious with when the temperature scale goes below 0. So remember, a big negative number means really cold, okay? So the coldest temperature here is -35, so that is going to be the slowest particles, or the lowest kinetic energy. The hottest temperature here would be 1, so that would be the highest kinetic energy. So you've got to get all these negative numbers in order. So then that's going to be the next coldest, and then this one, and then this one. Okay, so just be careful if there's negative numbers in there, and that's all you need to worry about for this one.